Welcome to our video on dial and digital calipers. We're going to focus on the dial caliper because the electronic digital caliper is so simple to use. Just has a few buttons on and off, absolute, incremental, inch, metric, zero. So it's very simple to use, but the dial caliper is just a little bit more difficult. So we're going to look at some techniques and some capabilities of this caliper. We have outside jaws. We have inside jaws. We have a way to measure a step on the back, and with this rod coming out the back we can measure depth, the depth of a hole or a step. So you can see this is a typical Brown and Sharp caliper, and let's take a look at how to read this instrument. On the graduated beam here, which is right here, it goes all the way down to 6 inches. This is a 6-inch dial caliper. We see an 8 showing. That's 8/10 of an inch, or 800 thousandths. On the dial we have 53 thousandths. So we have 853 thousandths. Very simple instrument to use. And if we pull it out just a little bit further, we see a 1 inch. And then we see a 4. The 5 is covered up. So we have 1 inch, 464 thousandths. And usually the accuracy of a typical dial caliper, a good dial caliper, is about plus or minus 1 thousandths. It really depends on how good it is, how it's been taken care of, and some other considerations like that. So let's do a little bit of measuring with this to show you how we use it. First we'll measure outside. The way we measure outside is we put the calipers on the part. I'd usually give it a little tilt. And it looks like we have 750 thousandths, which is what it should be. You see the 7 on the graduated beam, 50 thousandths on the dial. Add them together, you get 750 thousandths. Okay, now be careful of pushing too hard. You notice I get 750 thousandths on the dial right there. But see, if I push just a little bit hard, I can lose about 4 thousandths right there. So be careful, because they do have a little play in them. So if I measure outside, I get 750 thousandths. Okay, so now let's measure depth. We'll measure the depth of 2 counterbore hose in this part a student had made. So we use our depth rod. We're going to drop it in, get it right against the edge of the hole, and pull it down. And we see that we have 392 thousandths on that hole. This hole is just a little bit different. So we're going to set it up. We're going to put it right against it. We don't want it slanted. We want it right against the hole. We're going to pull it down, and we get 493 thousandths. 493 thousandths. So there's about 100 thousandths difference between the depth of the 2 holes, and we can obviously see that. Now to measure inside, we put the inside jaws in the hole, and we're going to just twist just a little bit, and we get 498 thousandths. On the counterbore hose we get 376 thousandths, and as we measure the outside diameter here, we get 2 inches, 250 thousandths. That is exactly what it should be. On the length we get 3 inches, 250, maybe 51 thousandths. That's right where it should be. And the thickness should be 7/8, which is 875. And looks like we're getting about 876 thousandths. So this is very well machined, other than the depth of the 2 counterbore hose. Now when we measure step, it's a little bit different. We can measure step with, this is a typical V block that a student made. You'll get to make one sooner or later. We're going to use, again, the face of the calipers, and we're just going to slide this back right up against it. And we get 198 thousandths. Just a couple more thousandths and we would be at 200. We measure the other side. We want the calipers to set nice and flat. See how they're setting nice and flat? And then we're just going to slide right up against it. And on this side we get about 205 thousandths depth. So that's how we measure step, depth, outside, inside. Now we do have a big part here that we can measure, again using the step method, which is very, very popular. We want the calipers to set flat, flat this way, and we just slide them in until they hit. So we get 1 inch 265 thousandths. So the measurement here on that step would be 1 inch 265 thousandths as we measure from this edge to this edge. Now it's probably not a good idea to measure like this. Too many variables. We can wiggle this way, we can be off this way, and some people will try to measure like this, but there's just too many variables. Here we have a nice flat surface and a nice flat surface, so it's best to measure a step using the back of the calipers. Now the last thing I'll show you is how to measure a drill. This is a typical 5/8 dimming drill, and we're going to start on the land, and then we're going to get to the margin. So we're going to start on the land right here, and we're going to slowly twist the drill until we get to the margin, which is 625 thousandths. 625 thousandths, that is a 5/8 drill. So we just bring the outside jaws in, slowly twist the drill until we get to the margin, and it will go up to 625 thousandths. We got to be careful about measuring at the bottom too, because here we have a little less than 600 thousandths. So when you measure a drill, don't measure it here. You notice this is slightly off as well. I'm down at the bottom of the drill, and I'm getting 622 thousandths, it looks like. So we always want to measure on the cutting edge on the margin. Okay, so we've learned a few basics here. The last thing I want to show you is do not buy plastic calipers. These are plastic calipers from Home Depot or Lowe's. Don't buy these, they're not good. Even if they have a dial on them, they're not very good. Plastic does melt, and we work with hot metal quite often, so stick with a good brand. Brown & Sharp, Starrett, Fowler, SPI. I like Brown & Sharp myself, but you can spend anywhere from $19 to $400 on a set of calipers. So this has been our video on the Dial Caliper. Good luck in your lab session, and I'll see you when we meet up on Monday or Wednesday. Have a good day.